Hi everybody, welcome to the first section in trigonometry. On this section, we just introduce some terminologies. Alright, angles. A ray is a half plane made up of point on a line, called the end point, and all the point on one side of the end point. So pretty much what we have is an end point. Right. So, and there's an end point, and then on the point on the other side. An angle is formed by rotating a ray by its end point. So we have one ray, and we rotate that. And the first one is called the initial side. So initially we have one ray, this one. And when we rotate an angle, that gives us the terminal side. The end point, the common end point, is called the vertex. And if we rotate an angle that is counterclockwise, that is a positive angle. And if we rotate clockwise, it is negative, just by convention. Right. Next, degree measure. We define an angle that rotates one complete revolution is 360 degrees, denoted by 360 with the little circle on the superscript. So if it is counterclockwise, not stroke, counterclockwise, and one complete revolution is equal to 360 degrees. So one revolution is equal to 360 degrees. And 1 degree is 1 over 360 of one complete revolution. Or we have 1 degree equal 1 over 360 of a revolution. Right. Next we classify angles. An angle that is between 0 and 90 degrees, that is an acute angle. 90 degrees is a right angle. Obtuse angle is from 90 to 180, and the straight angle is 180 degrees. So, just some simple terminology there. Right. Next, complement and supplement of an angle. So at this point, we define two positive angles that are complement if the sum is equal to 90 degrees. So, complement is the sum of the angle is equal to 90 degrees. Right. And here we will define only for positive angle. If one of them is negative, it will not work here. Like I said, it's just the way we define it. Later on, the properties doesn't require that the angle to be positive. There's some certain properties of complements and supplement angle that does not require an angle to be positive. But we'll talk about that later. Right, also. But for now, for definition, we define for positive angle. So supplements, if the sum is 180 degrees. Right. Let's look at the first example. Find the complement and supplement of this angle. First, the complement. A complement of 73 degrees is some angle. So let's say we can use anything. Take the angle A, or here we use the angle theta. By the way, that is the Greek letter theta. So let's say the complement is an angle theta. In this case, complement add up to 90 degrees. Solving for theta, 90 minus 73 is 17 degrees. And don't forget, we have to write the degree. It's the unit of that angle. Right, supplement. Supplement add up to 180 degrees. So theta equal to 180 minus 73. It is 107 degrees. Right. Next, 110. Find complement. Will add up to 90 degrees. So theta equal to 90 minus 110 equal to negative 20 degrees. And just by the definition that we have here, because of a negative, we say there's no complement. Because the way we define it, both of the angles must be positive. Supplement. So theta equal to 180 minus 110. That's 70 degrees. Right, so very straightforward there. Right, so we have 1 degree is equal 1 over 360. It's kind of small already. However, sometimes it's not small enough. If we want to be even smaller, we will say 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. And we have 1 degree is equal to, by the way, this is the second as a unit. Do not use S for second, because if we use S for second, that is the unit of time. This is the unit of angle, so we use that apostrophe there. So 1 degree is equal to 60 minutes equal to 360, 3600 seconds. And that is minute. Right, the reason we denote that differently than we spell out minute, because minute also a unit of time. So that's why we have to use different notation. And this is second. Right. Now let's look at some example. Let alpha, and this is the Greek letter alpha, and this is the Greek letter beta. Beta, sorry. is a little bit as a B. Right. Now let alpha be that and beta be that. Find A, alpha plus beta. So when we do this, we just add writing like columns. So 46 degree, 42 minute, and 12 second, plus 31 minute, 31 degrees, 54 minutes, and 17 seconds. Right, so when we add them, is from right to left, just like when we add numbers. 12 and 17, that's 29 minutes. So there's no carryover. 42 and 54, that will be 90. Will be 96. But 96 minutes is more than 60 minutes, and every 60 minutes is 1 degree. So we'll carry 1. So I'm just going to write scratch here. Add them up, we have 96 minus 60 is 36. So we're going to have 36 minutes, and then carry 1 over. And that will be 78 degree. Right. If we have a calculator, a TID4, we can certainly add them. So you see there's above this purple button, there's an angle. So that's what we use. Yeah, above the purple button, there's an angle. So 46. Hit second, that button, degree, 42, that button, minute, and then 12, where's the second? You see there's a like a quotation mark here, that actually is for second as well. And then we're going to add 31 minute, 54, 31 degrees, 54 minutes, and 17 seconds. I'm sorry. Suppose you hit alpha and that key, right? And of course that's not what we have for the answer, but if we hit second application and number 4, convert to degree, minute, second. So go to number 4, and we have 78 degrees, 36 minutes, and 29 seconds. Right, so that's how we do it using the calculator. Now let's find alpha minus beta, but we do by hand first, and then we use a calculator. Right, 46 degree, 42 minutes, and 12 seconds. Subtract 31 minutes, 31 degrees, 54 minutes, and 17 seconds. Right, so first, when we subtract 12, does not subtract 17. So we have to carry 1 over. So to carry 1 over, this is no longer 42, it's going to be 41. And when we carry over, we have at 60, 1 minute is 60 seconds, so we add to this, and that makes it 72. Now 72 minus 17 is 55 minutes. And then we have 41 minus 54. Again, 41 is less than 54, so we have to carry something over. So 46, now down to 45 and 41. So when we carry 1 degree over, that's going to be 60 minutes. and add 60 to this, we have 101. 101 minus 54 is going to be 47. And then 45 minus 31, that is 14. Right. So we just subtract these two. Of course, we can type everything again, but since you have this on a calculator already, if you use NTI 83, you will hit second, enter. One more time, second, enter. So I just pull up the last entry, and then we go back and change to negative. Right. If you use NTI 84 like this, we just hit the arrow, go up. Again, second entry to get the last entry. Or if you can highlight, hit enter, and now change to subtract. And second angle, number 4. Actually, we don't even need to do that. We just go up, highlight, hit enter, and yeah, that's what we have. Right. Next, find the complement of the angle B. So, the complement of the angle B, of course, is going to add up. Beta. The complement of the angle beta. So at beta, let's say this is complement, is add up to 90 degrees. So we just take 90 degrees minus that. Right, have to be a little careful here. Let's say we have 90 minus beta. Yeah, that might not be right here. 1 minute, 54, 31 degree, 54 minutes, and 17 seconds. Right. And convert to degree, minute, second. Like that. Alright. Now, of course, I didn't put 90 degrees, right? Let's do that again. See? So what's the problem there? So, of course, it's not going to be the negative 30 degrees, right? So what is the difference here? Of course, the 90, if we didn't put anything, is fine. But so the point here is, if we're going to use that, make sure you have to enter 90 minutes. 0, 90 degrees, 0 minute, and 0 second. Then that will be correct. So don't type the 90 degree by itself like this. If you enter degree, have to tell the degree, minute, and second when you do this operation, right? So don't put the 90 degree by itself. That could be wrong. Anyway, of course we can convert to 58 degree, 5 minutes, and 43 seconds. Right. So that is degree, minute, second. Now if we have a degree, minute, second to convert to decimal degree, do we have decimal degree? Nope. Do we? No, it doesn't matter. We just enter an angle alpha 46 degree, 42 minutes, 12 second. If we just hit enter, it will convert to a decimal degree. So we say 46 degree 42 minutes and 12 seconds equal to 46.703, yeah, let's say 3 decimal places degrees. So that is decimal degrees. Right. More terminologies. So we say that an angle is one ray rotating angle, and that's how we define angle. Now, if an angle in the standard position, an angle in rectangle coordinate system in the standard position, if the vertex is at the origin, so we rotate with the center, the vertex at the origin, and the initial side is the positive x-axis, so all the angle in the standard position rotate from this initial rate, and then we rotate so something like this is an angle in the standard position. An angle in the standard position is quadrantal if its terminal side lie on the coordinate axis, meaning that it could be here, here, or here. Of course, can be that as well. So that is quadrantal angle. If it is not in one of those rays, then it is said to be lie in a certain quadrant, and we say quadrant 1, 2, 3, 4 counterclockwise like that. So quadrant 1 is from 0 degree to 90 degree. Quadrant 2 is from 90 degree to 180 degree. Quadrant 3, of course, it can rotate more than this. An angle in reality make it go around and around as many times as we want, clockwise, counterclockwise. But now if we define the clockwise, and that would be, of course, there will be more than just this, but for now it's 180 degree to 70 degree, and then from 270 to 360 is quadrant 4. Later on we know that it will be more than that. Right. Next, draw each angle in the standard position and state the quadrant that it is in. Right. 45 degrees. So we know 90 degrees is the right angle. 45 degrees, of course, will be half of that. And of course, we're going to say the direction counterclockwise. So this is 45 degrees. And of course, that is in quadrant 1. 120 degrees. So where is 120 degrees? We know one complete revolution is 360 degrees, right? If we go one complete revolution, it is 360. If we start from here, divide that in 3 equal pieces, that is 120 degrees. So 120 degrees. So that is 1/3 of a revolution. So this is 120 degrees. And that is in quadrant 2. Negative 210. So a straight angle is 380. So this is a little more than a straight angle, but this is a negative angle. So we have to go clockwise now. So that gives us 180 degrees, a straight angle, and then it go a little more. So that is negative 210 degrees, and when we draw that, it is in quadrant course, that is not exactly 210 degrees. We just estimate. That is in quadrant 2. Right, 405 degree. This is positive, so we go clockwise. I mean counterclockwise. One revolution, that is 360 degree, right? And then it have to be a little more than that. So by how much? 405 minus 360. It's going to be 45. Degrees. So this is at the same as 45 degree. That is 405 degree. So we have to, indeed we have to denote the motion. So we start from positive x-axis and go on extra revolution to 45 degrees. Right, and this is what's in quadrant 1. Right, so what we see here is the 45 degrees and the 45 degrees, we have the same terminal ray, and there is a terminology for that. And so the coterminal angles are angles that have the same terminal size. Of course, in standard position, they should have the same initial size as well. So, coterminal angles. Coterminal angle is the same terminal sign. Of course, the initial sign, like I said, in the standard position, they are the same anyway. So that's why we call it coterminal angles. And the relation of coterminal angles is we just add a multiple of 360. So that is the coterminal angle. Is that angle plus a multiple of 360. So n is an integer. So because 360 is a revolution, so we just add one revolution, we get back to the same position. We can add a multiple of a revolution, or could be the other way. We could subtract. We could write subtract as well. But n, of course, here could be negative, could be positive, but it has to be an integer. Right? Because integers meaning negative 2, negative 1, could be 0, could be 1, 2, and so on. So, like that. Right. Find an angle between 0 and 360 degree, that is coterminal to each of this. So, we're trying to bring an angle to an angle between 0 and 360 degree. If it is more than 360, we subtract. If it is less, we're going to add 360 to it. So here we just subtract 360 degree. That is 130 degree. And if it is less than that, we can add 360 degree to it. So when we add 360 or minus 360, we have the coterminal angle. And again, if we want the angle between 0 and 360, if it is more than that, we subtract. If it is less, we add. So the angle is in between 0 and 360. And that gives us 210 degree. By the way, if we have like 800 degree, if we subtract 360 and it's still not between 360, we subtract more until we have the angle between 0 and 360 degree. So that minus 210, so that is 80 degree. So those 880 degrees, those are coterminal angles. Right? Right, next, find two coterminal angles, one positive and one negative. That is coterminal to 120 degrees. So from 120 degree, if we want coterminal angles, we can add 360 to it. and then we have 480 degrees. And we can keep adding 360 to it, but we want one positive and one negative. If we just keep adding 360 to it, it's not going to be negative. So we have to subtract. And that gives us negative 240 degrees. And of course we can still subtract 360 if we want to, but here we have one positive and one negative. Both of them are coterminal to 120 degrees. Right. Next, angle and lines. So this is some basic trigonometry. I should say basic geometry. Two lines in the same plane are called coplanar lines. So two lines on the same plane. Now, if they intersect, it will form four angles, and we have the pairs of angle 1 and 3. So angle 1 and angle 3. Those are vertical angle because each share a vertex, and vertical angle are equal. Then angle 2 and 4 are vertical angles, and they're the same. Also note that angle 1 and angle 2 add up to 180 degrees because that is the straight angle, right? So angle 1 plus angle 2, or 2 and 3, or 3 and 4, or 4 and 1, all of them add up to 180 degrees. Right. So if we have two intersecting lines, here's what we have. Now if we have two parallel lines, and we have one line that intersects both of them, so we have two parallel lines, and the line that intersects both of them is called the transversal. And with the transversal there, break it down into some relation between these angles. So first, the corresponding angles. For example, the 6 and the 2. Those are called the corresponding angle. Or angle 1 and 5. So those are the corresponding angle. Next, the alternative interior angle. So that means it is inside interior, but it is alternate. And they are also equal. Of course, the 4 and 6 also are equal because those are alternate interior angles. Now, interior angles on the same side of the transversal are supplement, meaning that like an angle inside, but on the same side of the transversal. Those are interior on the same side. So pretty much when we have two parallel lines in the transversal, if the angle are not equal, there will be supplement. So let's pick any two random angle, 1 and 7. Oh, they're the same because both of them are obtuse. A and 2, they are the same because both of them are acute. How about 5 and 2? 5 and 2, one acute and one obtuse. So they supplement. Like I said, if they're not equal, there will be supplement. Right. So pretty much in this section we go over the basic terminologies. Let's see. Define an angle. Complement and supplement. Complement add up to 90 degrees. Supplement add up to 180 degrees. But this definition, we define the angles are required to be positive. and then we can add or subtract angle in degree, minute, second. Then we define quadrantal angle will be 90. Quadrantal angle will be multiple of 90 degrees. Could be 0, 90, 180, 270, 360, so far, so on. Could be negative of those as well. And then we have coterminal angles. Coterminal angles have the same terminal sign, and to get to coterminal angles, we can add or subtract multiple of a revolution or 360 degrees. And then we have the relation of the angles, vertical angles, and all the angles from the transversal and parallel lines. Right, so that is the first section in trigonometry. See you in another video. Thank you for watching.